Hi guys! So we are from Group 2. This is Ricardo Adelino and Noriel Garrido. So I am Shane E. Esrera and I am leader of Group 2. So our topic is all about isomerism.
What if I tell you that there are many carbon compounds which possess the same number of atoms in them but have completely different structures? What do I mean? Can there be compounds that have the same number of atoms of each element in them but arranged differently? Yes, this is the concept of isomers. Isomers is the term that originated from the two Greek terms, iso meaning same or equal and meros meaning parts. Thus, here the term represents the compounds that have exactly the same number of atoms of each element in them. However, the arrangement of these atoms is completely different. For the sake of understanding, let us assume we have a compound like this. There are 2 atoms of A, 1 atom of B and D, and 3 atoms of C. Now look at this structure. The number of atoms of each element is the same, but the structure is different. There could be many more combinations that could rise if we rearrange the atoms. All these structures can be called as isomers of each other. How do we define isomers then? Isomers can be defined as the compounds which have the same molecular formula but different structural formula and thus different properties. That means if we take molecules of the isomers and compare them, then the number of atoms in each molecule will be the same, but their structural or spatial arrangement will be different.
Now, we are only going to talk about the 2 main types of isomerism, structural or constitutional. Compounds that have the same molecular formula but different connectivity of atoms. Stereoisomerism, compounds that have identical formula and connectivity but differ in arrangement of atoms in space. Let's give an example of structural isomers. Here we have butane and isobutanol, the same number of carbon C atoms and hydrogen H atoms, so their molecular formulas are the same. However, each one has a different structural formula, which shows how the atoms are arranged. So we can say that butane and isobutane are structural isomers. Now we are going to give an example for stereoisomers. Stereoisomers are isomers that differ in spatial arrangement of atoms. So, here take a look at this. Quite complicated to understand, is it? Actually, it is easy. Just take a look at those formulas. Notice that they are the same, both the right and the left formula. The only difference is that their arrangement in space. Now, I'm going to list the uses of isomerism in various fields. First is the chemistry. Second is the pharmaceuticals. Third is the biochemistry. Fourth is the materials science. Fifth is the environmental science. At first look, isomerism might not be related to criminology. However, understanding isomerism can be beneficial in forensic chemistry, where the analysis of drugs, toxins, and other substances is crucial. Isomerism can affect the properties and effects of substances, which can be important in criminal investigations involving drug trafficking, poisoning, or other chemical-related crimes. Isomerism demonstrates how molecules with the same molecular formula can differ structurally or spatially, resulting in unique properties. This diversity is crucial in chemistry, biology, and forensic science, influencing drug design, toxicity analysis, and the identification of substances Techniques to distinguish isomers are vital for legal, medical, and environmental investigations. So question, how can advancements in isomer analysis enhance forensic science, pharmaceuticals, and environmental protection?